Hello students, welcome to my YouTube channel Learn and Travel with Shuchishmita. Today I will discuss about the statistics in this class. So let's start. Okay. So in this chapter we will know what is statistics and where do we use some example, and also we will know variable, frequency distribution and cumulative distribution. Okay, so first, suppose you have a lot of information such as age, height, okay, weight of different people. So here we arrange this data in a systematic way. Okay, so here we use this data in order to look at the group. Okay, so now, what is statistics? Statistic is the collection of data. Statistics is the collection of data that teaches you how to collect, analysis and interpret the data. Okay, and make decision. So statistics is the collection of data, the weights of different people, okay, the heights of different people, okay, the marks of the students in class 9. So statistics is the collection of data that teaches you how to collect and then analysis, then interpret, okay, the data. So where do we use the statistics? It is used by organization like government, in industry, okay. So it is used by any organization like government and any company, okay. Some example: statistics of marks of students in class 9, okay. So this is the statistics, okay. The heights of all students in class 9. Okay, so here you see some data. Okay, so what is data? Now consider the marks obtained by 6 students in a class 9 in a test exam. Okay, so consider the marks obtained by 6 students in a class 9 test exam. So now student A got 2 mark, V 6 mark, C 7 mark, D 9 and E 8 and F 4. So here the set of mark out of 10. Okay, so here the set of marks 2, 6, 7, 9, 8, 4. Okay, this is the set of marks. So each called set of data. Okay, so data, what is data? A set of collected numerical facts is called set of data. Okay, here the set of the collected numerical facts 2, 6, 7, 9, 8, 4, this is the set. Okay, so it is called data. Okay, now another example. Suppose Ratan met with his new friend dog. Okay, so here these dog have a family. Okay, now the weights of the dog's family, for A dog the weight 5. Okay, this is the name, this is weight. So for dog A the weight is 5, for B weight 4.5. Okay, for C weight is 5.2. Okay, 5 kg, 4.5 kg and 5.2 kg. Okay, so here you see 5, 4.5 and 5.2 are the data, set of collected numerical facts. Okay, this is the data. So statistics is the collection of data that teaches you how to collect, then analysis, then interpret the data. Okay, so we use statistics in an organization like government, company. Okay, and some example are here, and after that we know the data, what is data. Okay, then we will learn variable. Okay, so what is variable? a quantity, okay, that can be counted or measured and which can vary from one individual to another, okay, it is called variable. So a variable is a quantity that can be counted, okay, and vary from one individual to another, okay, it's called variable. Some example: weight, okay, height, age, okay, page of a book, these are the variable, okay. Here you see weight in a class 9, weight are vary from one individual, from one student to another, okay. Suppose for one student the weight is 5.2 kg, or the weight is the weight is 30 kg, okay. Then for another students weight will be 30.2 kg, so it will be change, okay, from one individual to another, and this is a quantity that can be counted, okay, so it is variable. Now we know two variable, one is continuous variable and another is discrete variable. So first we will discuss continuous variable. Okay, what is continuous variable? A variable which can take any numerical value within a certain range is called continuous variable, and it is not fixed, okay. So continuous variable is a variable which can take any numerical value within a certain range. Is called continuous variable. And it is not fixed, okay. So some example: heights of children, okay, heights of children. Here you see height will be 3.5 feet, 3.75 feet, okay, 4 feet. So height, this variable, so height is the variable which is not fixed, okay, it is not discrete number, it is continuous number, okay. So any which take any numerical value in a certain range, 3 to 4, from 3 to 4. Okay, or we can take 3 to 5 range, 3 to 5 range, 3 to 5 interval, we get 3.5 feet, 3.75 feet, 4 feet. Okay, so in a certain range, in a certain interval, we can take any numerical value. Okay, this is called continuous variable. Okay, it is not fixed. And another example will be age and weights. Okay, and weights of person, weights of person, salary of person will be 9.5k, 10k. Okay, so these are continuous variable. Okay, temperature will be changed. Okay, and it will be 50.1 degree centigrade, 49.5 degree centigrade. Okay, so it is not fixed, and in a certain range we will take any numerical value. So this is continuous variable. Then next is discrete variable. Discrete variable. So what is discrete variable? A variable which is incapable of taking all possible numerical values. Okay, is called discrete variable, and it has a particular fixed value. Okay, so discrete variable means a variable which is incapable of taking all possible variable. So all possible values, numerical value. Okay, values is called discrete variable. Discrete variable. And here you see it has a particular fixed value. Okay, particular fixed value. So it will be 0, 1, 2, 3 dot 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 infinite. So here you can't see point the decimal value. Okay, so this is the fixed value, and this variable is incapable of taking all possible numerical value. That means it will not take the decimal value. Okay, so this is the discrete variable. Suppose example, number of children in a family. Children in a family. Okay, this can be between 1 and 2, between 2 and 3, and there is no fixed value between 1 and 2. Okay, this is the discrete variable. Okay, so this will be 1 or 2, not 0.5. Okay, not 0.6. This will be 1, 2, 3. Okay, another example is number of pages, okay, in a book. You can count the pages 50, 60, but you can't have 50.1 page, okay, it's never possible. So number of pages in a book, okay. Now we will know raw and arrayed data. Arrayed data, okay. So first you consider the marks obtained by 20 students in a test, okay, out of 50 marks, okay. So first we consider the marks obtained by 20 students in a test out of 50 marks, okay. So 8, 20, 50, 39, 34, 49, okay. 20 students got the marks out of 50 marks, okay. So here you see this data. Here the data in the form is called raw. It can't arrange, okay. It is obtained in a original form. So this is called raw, okay. Here you see the data in the form as given above is called raw or ungrouped data. That means it can't arrange and it is in the form of original. It obtained its original form. Now arrayed. What is arrayed? Arrayed. If the above data, this data, here you see this data in arranged form, okay. So it means this data in ascending order or descending order, it is called arrayed data. This data will be arranged, okay. So if the data is arranged in ascending or descending order, is called arrayed, okay. Arrayed data. So arrayed data in ascending order you see 8, 20, 34, 34, 39, 49, 39, 49, 50, okay. So this is the ascending order, and in descending order, it will be 50, 49, 28. Okay, so this is descending order. Now we will read tabulation of data. So what is tabulation of data? Tabulation of data. So such a representation of data in the form of a table, it is called tabulation of data. So this will be in the form of table. Okay, it is called tabulation of data. So these data are in the form of a table. Okay, this is tabulation of data. Now frequency. So what is frequency? So frequency is a number which tells how many times does a particular data occur, okay, in a given set of data. So it is a number which tells how many times does a particular data occur or appear in a given set of data. Okay, so how many times the answer occur? Okay, this is frequency. Suppose consider the following set of data. One, 2, 0, 3, 2, 1, 5. Okay, 1. So this is the set of data. So here you see 1 appear 3 times. Okay, in the given set of data 1 appear 3 times. So the frequency of 1 is 3. And you understand this, what is frequency? So frequency means it is a number. Okay, there you see 3 is a number. Okay, so this number how many times appear? A particular data. In this particular data set, here you see 1 appear 3 times. Okay, so the frequency of 1 is 3. Okay, now frequency distribution. Frequency distribution. So what is frequency distribution? A tabular arrangement of data. Okay, this data will be in a table. Okay, we will arrange in a table. So the tabular arrangement of data showing their corresponding frequencies is called frequency distribution. Okay, so frequency distribution is a tabular arrangement of data showing their corresponding frequencies. Is called frequency distribution. Okay, so now consider the following data. Okay, example, shoe size of 90 pupils. Okay, so the data set is 4, 3, 5. This is the shoe size 5, 6, 5, 6, 5. Okay, 6, 3, 6, 3, 3, 6, 4, 6, 6, 6, 4, 5. The shoe size of 19 pupils. Okay, so here you see a table as shown below. So here you see the size. Okay, here size is, one size is 3, then 4, 5, 6. Okay, 4 sizes here, 3, 4, 5, 6. Now we will construct a telemarks table. Okay, telemark. We will construct a telemark table, and then we construct a frequency table. Okay, so you see what is telemark. So here we write the variable in first column. Okay, this is the first column, and we take the observation from the given raw data in a telemark column. Okay, so what is telemark? You see 3 appear one time, 2, 3, 4 times. So here you see telemark is 4. So this is telemark. Okay, mark a stroke. Okay, called telemark in the second column. Okay, and frequency will be 4. Now 4 is appear one time, 1, 2, 3 times. So telemark is 3 and frequency will be 3. 5 will appear 1, 2, 3, 4 times. So telemark 1, 2, 3, 4 and frequency will be 4. Now 6 will appear 1, 2, 3, 4, 5, 6, 7, 8 times. So 1, 2, 3, 4 and this will be 5. Okay, we can write telemarks. When we write telemarks in bunches of 5, then fifth one crossing the 4 diagonally. Okay, so when we write telemark in bunch of 5, okay, this 1, 2, 3, 4 and this is the 5, then fifth one crossing the 4 diagonally. Okay, So this is fifth. Now we have 8 times appear 6. So 6, 7, 8. Frequency 8. Okay. And then in the third column we will write the frequency. Okay. Now we will discuss type of frequency distribution. So there are two types of frequency distribution, inclusive and exclusive. Okay. So two types of frequency distribution. So first is inclusive and second is exclusive. So what is inclusive distribution? So in an inclusive distribution, the upper limit of one class does not coincide with the lower limit of the next class. Okay. So inclusive distribution the upper limit does not equals to the lower limit. Okay. So upper limit of one class interval does not equal the lower class or the lower limit of another class interval. Okay. So the upper limit in inclusive distribution, the upper limit of one class does not coincide with the lower limit of next class. Of the next class. Okay. See the example 1. Here you see the example 1. Okay. You see here in the interval 1 to 10. Okay. The previous class, you see previous class, the interval 1 to 10, and in the next class the interval 11 to 12. So 10 in the upper limit of one class, it's not equals to the lower limit of the next class. Okay. So this is the inclusive distribution, means the upper limit of one class does not coincide. Okay. Here 10 is not in the second class. Okay, second class interval. So this the upper limit of one class does not coincide with the lower limit of the next class. This is the inclusive distribution. Okay. So follow the example 1. Example 1. Okay. Now exclusive distribution. So exclusive distribution. So what is exclusive distribution? Here you see upper limit of one class interval is equal to lower limit of next class interval. That means here you see the upper class limit of one class coincide with lower class limit of next class. Okay, so here you see the upper class limit of one class coincide with lower class limit of next class. Okay, see example 2. Here you see the example 2. Here in the previous class interval the upper class limit 20 and in the next class interval the lower class limit 20. So this is equal. Okay, and the upper class limit coincide with the lower class limit of next class. Okay, this is the exclusive distribution. So follow example 2. Okay, now we will see class interval and class limit. Okay, class interval and class limit. So what is class interval? So in case of an exclusive frequency distribution, (10 to 20), example 2 you see. So 10 to 20 is called class interval. Okay, so here you see 10 to 20 is called class interval. Okay, and class limit, here you see 10 and 20 is called class limit. 10 is lower class limit in this class interval and 20 is upper class limit. Okay, in this interval. So now we will read adjustment. Okay, so what is adjustment? So adjustment means adjustment factor. Okay, we will find the adjustment factor. So adjustment factor is the difference between the upper limit of one class and the lower limit of the next class. Okay, and then divide this difference by 2. Okay, so it's possible only for inclusive distribution. Okay, so what is adjustment factor? The upper limit of one class minus lower limit of next class, that's divided by 2. Okay, it is called adjustment factor. So here you see in example 1, you see in example 1 in a inclusive distribution table. Okay, so here you see the class interval 1 to 2. Here the lower class limit is upper class limit 10, and in the next class the lower class limit is 11. So the difference between the first interval is 1 to 10, and then in next class interval is 11 to 20. So the adjustment factor will be the difference between the upper limit of one class and lower limit of next class. The difference means, here you see the lower limit of next class minus the upper limit of one class. Okay, minus the upper limit of one class. Okay, the difference between upper limit and the lower limit. Okay, so upper limit 10 and next class the lower limit 11. So 11 minus 10 by 2 will be 1 by 2. This is 0.5. So 0.5 is adjustment factor. So now we see the adjusted class. So here you see marks before adjustment, that is class, and marks after adjustment. Okay, this is called class boundary. And then next column is frequency. So here you see this column is, in this column 1 to 10 is class interval, then 11 to 20, then 21 to 30. Okay, so marks after adjustment will be subtract this adjustment factor 0.5 from lower limit and add 0.5 with upper limit. Okay, so this will be 0.5. We subtract the adjustment factor from 1 and then add to 10. So this will be 10.5. Then next 11 minus 0.5, so this will be 10.5, and this is 20.5 at 0.5 with 20. Now this will be 20.5. We subtract 0.5 from 21 and then add to 30, so 30.5. And the frequency 1 to 10 in example 1, frequency 6, this is 8, and this is 11. Okay, now we will know class limit and class size and class mark. Okay, so first class limit we know, class boundary. Okay, so class boundary after adjustment, the class limit is called actual class limit. This actual class limit is called class boundary. Okay, so after adjustment, we get class limit, actual class limit, actual class limit. So this actual class limit is called boundary. Class limit is called class boundary. Okay, then class size. So what is class size? Class size means the difference between actual lower limit and actual upper limit of a class interval is called class size. Here you see actual after adjustment, actual upper limit 10.5 and actual lower limit is 0.5. So the difference between upper limit, actual upper limit and actual lower limit is called class size. Okay, so class size is equals to actual upper limit minus actual lower limit. Okay, so here you see 10.5 minus 0.5, this will be class size is 10. Okay, now class mark. Class mark. Class mark means the midway between its actual lower limit and actual upper limit in a class interval. Okay, so class mark equals to actual lower limit plus actual upper limit by 2. Okay, so this is the midway, means midpoint of actual lower limit and actual upper limit of a class interval. Okay, now see this example. So here class interval is 0.5 to 10.5. So class mark will be the midpoint between 0.5 and 10.5. So this will be class mark. Here class mark is equals to 10.5 plus 0.5 by 2. So this is 11 by 2. So this will be 5.5. Okay, between. Now we will know cumulative frequency. So what is cumulative frequency and cumulative frequency table? Now see example 2, that is exclusive distribution. In an exclusive distribution, see exclusive distribution 10 to 20, 20 to 30, 30 to 40. So here this is the marks, this is the class. Then frequency is 4956. Now we have to find the cumulative frequency table. Okay, so what is cumulative frequency? So cumulative frequency of a class interval is the sum of frequency of all classes up to that class. Okay, okay, so now example 2, the class or marks is here 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Then frequency is here 4, 9, 5 and 6. Then we have to find the cumulative frequency. Okay, cumulative frequency. So here first we take the first value from the frequency. So here first value is 4, so first we take the first value of frequency, so this is 4. Then we add 4 with 9, this will be 13. Okay, then we add 4, 9 and 5, all the values, okay, up to that class. Okay, add all the values, that means 4 plus 9, 13 with this frequency. Okay, so this will be 18. Then we add, here we add 30 plus 5, 18. Then we add 80 plus 6, we will get 24. So this is cumulative frequency. First we take the first value of frequency 4, then we add the next one, so this is 13, and then 13 with 5, and then we add, we will get 18, then we add 18 plus 6, 18 with 6, then we will get 24. Okay, this is called frequency, cumulative frequency and cumulative frequency table. Okay, so now let's start the exercise 18a. Okay, exercise 18a. So you see here first question. Here you see the first question is, state which of the following variables are continuous and which are discrete. Okay, So first question, number of children in your class. Okay, number of children in your class. It is discrete. Okay, so here decimal point, it's never possible, only comes one student, so or one children, 2 3 4. Okay, so this is discrete, it is the fixed value. Okay, it is discrete. Now B, distance traveled by a car. Okay, it is continuous, it will be decimal values 10.2 kilometer, 4.5 kilometer, 1.2 kilometer. So this is continuous variable. Now C, size of shoes. This will be discrete. Okay, it has fixed value. Okay, now question number D, time. So this is continuous, we get 9:30. Okay, 9:15. Okay, so this is not discrete, this we will not get fixed value. Okay, so this is continuous. Now E, number of patients in a hospital. This will be discrete, here we get the fixed value. Okay, so this will comes 30 10 20 50. Okay, now question number 2, given below are the marks obtained by 30 students in an examination. Okay, so taking class intervals 1 to 10, 11 to 20, these are the class interval. Make a frequency table for the above distribution. So we have to make a frequency table for the above distribution. So here the frequency table for the above distribution is first marks. Okay, then this is the 1 to 10, 11 to 20, this is the inclusive distribution. So we have to convert this table into exclusive distribution. Okay, so actual class interval, okay, after adjustment, actual class interval, and then telemark, then frequency table. Okay, so first 1 to 10, here we have 30 students, so 1 to 10, 1 to 10, then 11 to 20, 21 to 30, and 31 to 40, 41 to 50. Okay, marks obtained by 30 students. Okay, and out of 50. Okay, so here we get This is the class interval, and after adjustment the actual class interval will be 0.5. so we subtract 1. Okay, so we subtract 1 from 0.5, subtract 0.5 or adjustment factor from 1, then add with upper limit, that will be 10.5, then subtract 0.5 from 11, this will be 10.5, and this is 20.5, add, then subtract 20.5 and add 0.5, 30.5, this will be 30.5, add 5, 40.5. okay, 0.5 with 40, then subtract 0.5 from 41, we will get 40.5, and this will be 50.5, add 0.5 here. Okay, so we count less than, in this interval we count less than 10.5. okay, we take here, we take till 10. okay, so we count less than 10.5. so in next class we take 10.5, but in previous class we do not take 10.5. okay, you understand? Here you see, in the class interval we take till 10, not 10.5. in the next class interval we take 10.5, we add, we count 10.5, but in the class interval we don't take 10.5. okay, so here telemark, you see here, okay, 0 to 10, 0 to 10, sorry, 0.5 to 10.5, less than 10.5 and greater than 0.5, we get the answers. So we occur the answers are 4. okay, 8, 9 and 2, 1. so telemark is here 4, 1, 2, 3, 4, frequency will be 4. so 10.5 to 20.5, C 10.5 to 20.5, 18, 14, 19, 11 and 16, 15. okay, so this is 6, 1, 2, 3, 4 and 5th will be in the diagonally. okay, so this is 6, so this is 6. Now 20.5 to 30.5, so 1, 2, 3, this will be 3, frequency 3. 30.5 to 40.5, so this is 4, 1, 2, 3, 4, telemark, and frequency will be 4. Now 40 to 50, 1, 2, 3, 4, 5, 2, 3, 4, 5, so frequency 5. okay, now question number 3. The marks of 24 candidates in the subject mathematics are given below. The maximum marks are 50. Make a frequency distribution. okay, it taking class interval 0 to 10, 10 to 20, so 20, this is the inclusive distribution. okay, so here you see Question number 3. So frequency distribution table is marks, telemark. So here we don't need to convert the class interval into exclusive or adjustment actual class interval. Okay, here this is the exclusive class interval, so this is the frequency. Okay, so here you see okay, so you see the class interval 0 to 10, and this is the exclusive class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, so this is the class interval. Then telemark, you count here 0 to 10, 1 2 3 4, so telemark 4, frequency will be 4. 10 to 20, 1 2 3 4 5 6, 4 5 6 6, and 20 to 30, 23 2 times, and also so 29. Okay, now 3, 1 2 3, frequency 3. Then 30 to 40, 2 times 30, so sorry 3 times 13, 35, so 4, 1 2 3 4, frequency 4. 40 to 5, 1 2 3 4 5, 1 2 3 4 5, so frequency 5. So here you see the marks of 24 candidate in the subject mathematics are given below. The maximum marks are 50. Make a frequency distribution taking class interval this. Okay, so here marks 30 in the class interval 30 to 40. So in this class interval 30 to 40, we take only here 30 to 39, but we don't take 40. In this class interval we take 40. Okay, now question number 4. See question 4, fill in the blanks. A quantity which can vary from one individual to another, we know it is called variable. Okay, so this is the variable. V, size of shoes are dash variable, so this will be, we know, discrete variable. There will be fixed point. Okay, fixed values 1 2 3 4, size will be size of shoes, so this is discrete variable. C, daily temperature is dash variable. Daily temperature 50.1, 49.5, 30.5, so this is continuous variable. Question number D, the range of data 7 13 6 is dash, so range will be, range is highest value minus lowest value. highest value minus lowest value. This is the range. Here you see in this data, you see highest value 25 and lowest value is 7. So 25 minus 7 will be 19. Okay, this is the range. Now E. In the class interval 35 to 46, the lower limit is 35 and upper limit is 46. Okay. Now if the class mark of class interval 22 to 29 is, so we know class mark is upper limit plus lower limit by 2. Okay, so here upper limit is 29 plus 22 by 2, 51 by 2. This will be 25.5. Okay, so next question we will solve in part 2. Okay.